Hi everyone, today I'm going to be teaching you lesson 13-3, which is graphing piecewise linear functions. So the warm-up for today is to take a pencil and to graph the equation f of x equals negative x plus 3. So let's just review what that means. So f of x equals negative x plus 3 is really the line y equals negative x plus 3. We're just using f of x notation to notate that a line is really a function. It passes the vertical line test. So to graph the line negative x plus 3, you need to remember the slope and the y-intercept. So the slope of the line is the coefficient of the x. So the coefficient of the x term is right here. That's negative 1. And we usually write the slope as a fraction. So I'm going to represent that as negative 1 divided by positive 1. That would equal negative 1. And then the y-intercept is located right here. It's a number being added or subtracted to your equation, which is the constant, and that's the number 3. So to graph this line, y equals negative x plus 3, I'm going to start at my y-intercept value, which is 3. So I'm going to go to the y-axis, and I'm going to put a point at the point 0, 3. Now I'm going to use my slope to generate additional points on the line. So if you go back up to your slope, the negative 1 is telling you the change in y, and the positive 1 is telling you the change in x. So that means to go down 1 on the y and over to the right 1 on the x. And I'm going to continue this pattern, down 1 over 1, down 1 over 1, down 1 over 1. Okay. And then instead of going down 1 to the right 1 to generate more points on the line, in quadrant 2, I'm going to go up 1 to the left 1. Okay. Now I'm going to draw my line in. Your line should look a little bit straighter than mine. So this is y equals negative x plus 3. Okay. Part A, done. Now we're going to go to part B. So we want to draw a dotted vertical line where x equals 1. So I'm going to use a different color. X equals 1. So I'm going to plot points everywhere that have x values of 1. So this would be the point 1, 0, 1, 1, 1, 2, 1, 3, and so on. I'm going to go in the into quadrant 4 as well. So 1, negative 1, 1, negative 2, 1, negative 3, and so on. So x equals 1 is a vertical line where all the points on the line have x values of 1. And the warm-up told me to draw a dotted line or a dashed line through these points. Okay. Part B is done. Now let's take a look at part C. So now we're going to restrict the domain of that function. So in order to restrict the domain, we're including only values that are less than 1. So we're going to erase the function to the right of the dotted vertical line at x equals 1. So what that means is that the vertical dotted line is really a boundary line. We're only keeping the line that's in blue, the y equals negative x plus 3, either to the left of the green dotted line or to the right of the green dotted line. The question is going to tell us which side we're keeping. So if you look back at part C, it's saying we're restricting the domain and we're only including values that are less than 1. So I'm going to take my eraser and I'm going to erase my line here. Get rid of these points that are to the right of my dotted green boundary line. Everything else I'm keeping. Okay. Now, we have to remember that less than means we have an open circle where the function intersects the line, because it's not including that value. So where my line y equals negative x plus 3 intersects the line x equals 1, right here, I should have an open circle. Because we're only keeping this line for x values that are less than 1, not for x values that are less than or equal to 1. I'm going to make the inside of that point look a little more white. There we go. Okay. Now let's take a look at warm-up part 2. Now I'm going to draw the line y equals 2x minus 5. And remember, f of x just means that we're talking about a function. So just like I did in warm-up part 1, I'm going to write down what the slope of the line is and what the y-intercept of the line is. So my slope of the line here is the coefficient of my x is 2, and I'm going to write that as a fraction, 2 divided by 1. And then the y-intercept is the constant that's being added or subtracted to the equation. So in this case, it's negative 5. Okay. So I'm going to start at my y-intercept to graph this. So I'm going to go down to negative 5 on the y-axis. Put a point, and then I'm going to use my slope to generate additional points on the line. So remember, slope is the change in y divided by the change in x. So this is telling me from the y-intercept value to go up 2 on the y-axis and then over 1 to the right, because we're talking about a positive one. So up 2, right 1, up 2, right 1, up 2, right 1, and then down 2, left 1, down 2, left 1. Okay. Oops. Now I'm going to draw my line in, and I'm going to label it y equals 2x minus 5. Okay. Part B, we already did. We drew a dotted vertical line for x equals 1. That's the line we have in green on the grid. Now, part C, we're going to restrict the domain for this function, the y equals 2x minus 5, but now we're going to include values that are greater than or equal to 1 by erasing the left side of the function. So to the left of the green dotted line, we're now going to erase. So I'm going to take my eraser. I'm just going to erase my line here to the left. Okay. And now let's make sure we have this correct. So if you read the following statement, greater than or equal to means you have a closed circle where your function intersects the line at x equals 1. So that means this function should have a closed circle when x is equal to 1, because we're including it. Okay. So what you see in blue here, I'll go over this in blue so you can see that it's part of our function, is your what's called a piecewise function. It's a function made up of 2 or more pieces of different graphs. So when we're writing the equation of a piecewise function, we first have to write down what the 2 equations are that we graphed. It could be 2 or more, but in this case we have 2 lines. So we said the first line that we graphed was f of x equals negative x plus 3. So on the top here, after the f of x equals in the brackets, I'm going to put negative x plus 3. And then underneath it, I'm going to put the second line that we graphed, which was f of x equals 2x minus 5. So when I look at this notation, what it's telling me is that I really graphed 2 different lines on the same set of axes. But the thing is, if I looked at this the way that I just wrote it, it looks like I graphed the lines in their entirety, when I really didn't. I only graphed a portion of the lines. So I have to notate which portion I graphed on my grid paper. So I'm going to go down a little bit further. I'm going to say, well, I graphed this y equals negative x plus 3 only when x was less than 1. So I have to notate that on my paper. So next to my equation, f of x equals negative x plus 3, I would have to write in, I'm only graphing that line for when x is less than 1. Now for my line y equals 2x minus 5, I only kept that graph when x was greater than or equal to 1. So I have to notate that as well. So a piecewise function is exactly what the name entails. It is defined by two or more functions such that each function applies to a different part of the domain or the x value. So we're not going to graph the two or more functions in their entirety. We're only graphing parts of each function. And the question is going to tell us which part of that function to keep. So let's take a look at one more together. So in this question, I'm given two lines to graph. I'm going to use another color here. So the first line I'm given to graph is f of x equals 3x minus 6. I'm not going to worry about the domain restriction, which is over here, just yet. First, I'm just going to graph f of x equals 3x minus 6. So off to the side, I'm going to say, okay, f of x equals 3x minus 6. My slope is 3. And again, we usually write the slope as a fraction, so 3 divided by 1. And my y-intercept is negative 6. So I'm going to start on the y-axis at negative 6. And then I'm going to use my slope to generate other points on the line. So remember, slope is the change in y over change in x. So change in y over change in x. So a positive 3 would mean I would go up 3, and a positive 1 would mean I would go right 1. So this is up, this is right. And I'm going to go down 3, left 1. Make this a little bit bigger so you can see it a little bit better. Okay, now I'm going to graph my line. And I'm going to label it f of x equals 3x minus 6, or you could have said y equals 3x minus 6. Okay, now the thing is, I'm only keeping this line for when x is greater than 2. So 2 is really what we call our boundary line. That's where things are changing at an x value of 2. As you can see down here, maybe I'll use a different color for this. Everything has to do with 2. That's where we're deciding at an x value of 2 which side of the line we're keeping. So I'm going to draw a boundary line, which is a dotted line, at x equals 2. Okay, so now when I look back to f of x equals 3x minus 6, next to it, I see x is greater than 2. What that means is we're only keeping this line for x values that are bigger than 2. So I'm going to erase the line where the x values are less than 2. Now I have to be really careful because it said I'm only keeping this line for when x is greater than 2, not when x is actually 2. So there really should be an open circle right here. So I'm keeping this line only for when x values that are bigger than 2. Now I have to graph my other line. Let's see, what color should we use? F of x equals negative 2x plus 6. And I'm only keeping this line for when x is less than or equal to 2. So I'm going to go down here. I'm going to say, okay, f of x equals negative 2x plus 6. So that means this is my slope, which is negative 2 over positive 1. Remember, slope is change in y over change in x. That means we're going to be going down 2 because the 2 is negative, and right 1 because the 1 is positive. And then the 6, the positive 6, is your y-intercept. So I'm going to start at 6 on the y-axis. And then I'm going to use my slope down 2, right 1 to generate other points on the line. Okay, and I'm going to draw my line in. I'm going to say this is the line f of x equals negative 2x plus 6. Okay, but now I have to look at what the equation is telling me. I'm only keeping this line for when x is less than or equal to 2. So what that means is I'm going to take my eraser and I'm going to erase my line for when x is 2 or for when x is greater than 2. When x is 2, I'm keeping the line because this condition says or equal to. So I want this line for when x is 2 or when x is smaller than 2. So that should be a closed circle there. And if you're having trouble seeing where you're keeping the line, what you might want to do is label your x-axis. So if I wrote on my x-axis that this is an x value of 1, this is an x value of 2, 3, 4, 5, 6, 7, 8, 9, 10. If I labeled the x-axis, and same thing going backwards. If you go back up to your conditions, the first condition we said was, okay, I'm graphing this line f of x equals 3x minus 6 for when x is greater than 2. So if you go to the x-axis, here's when x is 2. We want to keep that purple line when x is bigger than 2. So when x is 3, 4, 5, 6, 7, 8, 9, or 10, and even further than that, we would keep that line. Whereas when I look at f of x equals negative 2x plus 6, I'm keeping it when it's 2 or less. So I'm keeping it at 2 or smaller, which would be this way. So my pink line should be to the left of where 2 is. What I'd like you to do now is to complete the 2 practice questions. You'll notice the practice questions have evaluate follow-up questions. So let's just take a look at that before we end today. So the question is asking you to evaluate f of negative 1. What that means is that this is the x value is negative 1. What's the y? So I'm going to go to negative 1 on the x-axis. So here's negative 1 on the x-axis. And I'm going to look up and find my function. So I'm looking up, and I want to find the y value of my function when x is negative 1. When x is negative 1, I'm going to look over. I'm going to say y is 1, 2, 3, 4, 5, 6, 7, 8. Now I want to evaluate when x is 2. Now this is a tricky one, right? Because when I go to 2, and I look at 2, and I look up, right, I see an open circle right here, and then I see a closed circle. So when you're evaluating, you're looking for the closed circle point. So when my x value is a 2, my y value is really also a 2. And lastly, if they give me an x value of 5, I'm going to go to 5 on my x-axis. So here I am. Oops. And I'm going to look up, and I'm going to find my y value. So let's see, how much is that? 1, 2, 3, 4, 5, 6, 7, 8. When I look over here, that would be a y value of 9. Okay, so after you graph your piecewise functions, the 2 practice questions, please make sure you answer those evaluate questions on the side as well. Have a good day, everybody. Hope you're doing well. You could always email us with any questions that you have, or reply to your Canvas, to the Canvas submission message, and we'll get back to you ASAP.